Okay, so on the homework, we came across some questions about uh, vectors that are not completely horizontal or completely vertical. So I want to put a quick video together here to just talk about how to calculate the components or the vertical component and the horizontal components of the vectors. So you notice that this hypotenuse, the red line here, would represent the non-horizontal or vertical vector. So this might be a velocity v. So say a projectile is launched from the top of a cliff with some height h at some velocity v at an angle of theta. Well, in order to figure out, the question might be asking how long is it in the air or where does it land over here? Well, in order to do that, you need to figure out what the vertical v initial is and what is the horizontal constant speed. So it would be helpful if we could break these apart. So the hypotenuse then is v, um, and the angle that it's being launched at is theta. So to calculate the opposite side, you notice I wrote opposite and I put a big capital S here. That S is to imply that the opposite value is equal to, or the y component, right? The vertical y component of this. S is corresponds to the sine. So that opposite side, or the y component, is equal to sine theta times the hypotenuse, which is v. So that works out to be v times sine theta. And another worthwhile point here is this is the opposite side relative to this angle. This angle, if you go out across, this is the opposite side. So relative to this angle, if we had an angle here, and let's make that angle phi, relative to this angle, this is the opposite side. So remember that opposite and adjacent are relative to an angle. So this is our angle theta that our projectile is being fired at. So opposite side of that angle, and this is the adjacent side to that angle theta, adjacent to theta. And this is actually opposite to phi, and this would be the adjacent to phi. So you got to understand what angle it is you're looking at and what sides there are relative to the angle. So the hypotenuse is the vector v, and opposite side is here. So I'm gonna erase this implied portion under here just so you kind of see that I don't want to confuse you. Okay, so the opposite side is sine theta times hypotenuse, or v times sine theta. And the adjacent side, and you'll notice that I wrote this with a big C. C corresponds to the cosine. So the horizontal, or the x component of this vector v, is equal to cosine theta times the hypotenuse. And if the hypotenuse is then v, we could say that that's equal to v times cosine theta. Okay, so that works out very handy. Now, what if we have a situation where we have, like, say, a boat is traveling across a river, and the boat has a land speed of 4 meters per second. That's our little sailboat there. That's pretty cool. And it's going 4 meters per second relative to the bank in the water, but then the water, let's say this is going due east, and the water is flowing at 3 meters per second due south. Well, how fast will the boat travel relative to the land, stationary land? Well, in order to do that, we have to add these two vectors. So I'm going to add these vectors over to the side here. You could take them and just move this vector up here, but you have to add vectors heads to tails. So I'm going to redraw the vectors out here. So this is my 4 meter per second vector, 4 meters per second. And this is my 3 meters per second vector. Oh, come on. Let's make it straight. There we go. So this is my 3 meters per second vector. And here's the key component here. We got to make sure we're adding heads to tails. So the vector has a arrowhead and the tail of the vector. So we go arrowhead to the tail of the next vector and just add it that way. But here's another important part. You got to understand, where did you start the process? So this is where we started. And where did you end the process, which is over here? So then the resultant vector will be drawn from start to end. And we'll make that maybe this color right here. So from start to end of all the vectors that we're adding together, and that is our resultant vector. So the resultant vector is the x component plus the y component. So this is clearly a right triangle. And so this is a 3, 4, 5 right triangle. 3, 4, 5 right triangle. Well, in order to have the velocity is a vector. So it's 5 meters per second. That's the magnitude. What is the direction? So we need to know what this angle theta is here. So in order to calculate the angle theta, you can do any of the trig functions: sine theta, cosine theta, or tangent theta, because you know all three sides. Okay, so sine theta is opposite over our hypotenuse. And opposite of this angle would be 3 meters per second. And the hypotenuse is 5. So 5 meters per second. So 3 over 5 is 0.6. So sine theta is 0.6. Okay. So then cosine is the adjacent over the hypotenuse. And the cosine is 4 over 5, or 0.8. And then the tangent is opposite over adjacent. Opposite over adjacent, which is equal to 3 over 4, which is 0.75. Now, in order to find theta, because we have sine theta, cosine theta, and tangent theta, you can pick any one of these. Let's say this is our sine theta. We take into the calculator, we would say inverse sine of 0.6. 0.6 will give me theta. And theta works out to be 37 degrees.